Let's take a look at 1.1.1. We have x multiplied by x minus 3 being equals to 0. We're solving for x. It's either x is equals to 0 or x minus 3 is equals to 0. One between the two, right? So x equals to 0 or x is equals to 3. That is the answer to 1.1.1. We are sticking to the basics, really. Nothing complicated. Right. Let's take a look at 1.1.2. We have 2x squared plus 1 being equals to 4x, and we're supposed to solve for x correct to 2 decimal places. As soon as the question says correct to 2 decimal places, we are thinking that we might have to use the quadratic formula, the quadratic equation. So to write this in the standard format, we would have 2x squared minus 4x plus 1 being equals to 0. So this is A, this is B, and this is C. Right. So now we're going to say that x is equals to minus b. So minus b in this case is, well, 4 is minus 4 is b in this case, and then plus or minus the square root of b squared, right? So minus 4 squared minus 4ac. A is 2, c is 1, and then we divide everything by 2a, of which a is 2, right? So we have x being equals to. So without wasting time, let me just go ahead and substitute this in my calculator. So we're gonna have plus 4 plus the square root of minus 4 squared minus 4ac. A is 2, c is 1, divided by 2a. Well, a is 2, so I'm getting x is equals to 1.71, or x is equals to, so let me change the positive to a minus. We have 0.29. 0.29. These are our two answers, 1.71 and 0.29. There's no other answer except from this. 1.70 something is wrong. 0.293, 0.2928. It is completely wrong. The question says correct to 2 decimal places. There's no ambiguity when it comes to rounding off. So these are the only 2 possible options. Right, 1.1.2. Let's take a look at 1.1.3. So 1.1.3, x squared minus 2x minus 3 is greater than 0. So here we are solving for x. I'll go ahead and find my critical values, right? In saying that CV, right, I can then equate these to 0 and find those critical values of x, and then worry about the answer after. So x squared minus 2x minus 3, we can easily factorize this, right? 2 factors of minus 3, when we add, we get minus 2, and when we multiply, we get minus 3. That is minus 3 and plus 1. This is equals to 0. Well, we can test this out. This is going to give us x squared minus 3x and then plus 2x minus 3. So x squared, actually, let me do that again. I know that this is how it looks like when it's factorized. So x and x will give us x squared, and then we have plus x, and then we have minus 3x, and then we have minus 3. So this is going to be x squared minus 2x minus 3. Okay, so I've done that in the correct way. So these are the critical values. X is equals to 3 or x is equals to minus 1. Like I've said on countless videos, there's 2 possible solutions when we get to this point. It's either x lies between the 2 critical values or it lies outside. Let me show you what I mean when I say that. If it lies between the 2 critical values, I'm saying that x is between minus 1 and 3. And when I say it lies outside, I'm saying that x is less than minus 1 or x is greater than 3. These are the possible solutions, A and B. These are our possible solutions. There's no other solution apart from these 2. So how do we therefore test which solution is correct? I'm glad you asked. Take a look at this. So we can substitute a number that exists in this solution, right? A number between minus 1 and 3 is 0. If we substitute that number in our equation and our condition, well, our inequality is satisfied, then A is our solution. But if that is not the case, then B becomes our solution automatically. So let me substitute 0. 0 squared minus 2 multiplied by 0 minus 3. So when you substitute 0, we get minus 3 is greater than 0. Is this true? We know it is not. So it means that this is not the solution. This is not the solution. We can get rid of this. This is not the solution. So the solution, x greater than 3 or x less than minus 1. This is the actual solution. We can obviously test that out. We can substitute 4, for instance. When you substitute 4, we get 4 squared minus 2 multiplied by 4 minus 3. That is 5, and 5 is clearly greater than 0. So that is the solution, 1.1.3. 1.1.4, we have 2 to the power 2x minus 2 to the power x plus 2 minus 32 is equals to 0. So as soon as I see equations like this, I know that I'm going to let something be equals to k, right? I'm going to let something be equals to k. So let me show you how this plays out. So 2 to the power 2x, we can write it as, well, 2 to the power x, everything to the power 2, right? 2 just multiplies 2, just multiplies x, and we end up with 2 to the power 2x. And then here we can write minus 2 to the power x multiplied by 2 to the power 2, because when we multiply numbers with the same base, we add the exponents. So that is totally fine. And this we can leave as minus 32, and this is equals to 0. So we can let 2x be equals to k, right? In doing that, we will therefore have k squared minus 2 squared is 4, right? So we have minus 4k minus 32 being equals to 0. And then we can just go ahead and factorize this. So let me give that a try. We have k, and then 2 factors of minus 32, of which when we add, we get minus 4. I think minus 8, let's say minus 8 and plus 4 would work. Let's just give this a try and see. So this would give us k squared plus 4k minus 8k, 8, 16, 32, minus 32. So k squared minus 4k minus 32. So I'm quite convinced that what I've done is correct, right? That is how you can always check. You can just multiply out and see if you go back to the same thing. So k is equals to 8, or k is equals to minus 4. But we know that k is 2 to the power x. So 2 to the power x is equals to 8, or 2 to the power x is equals to minus 4. Obviously, we know that this is impossible. So we cross it out and we forget about it. Now let's focus on 2 to the power x being equals to 8, right? So 2 to the power x, we write 8 with a base of 2. So that is 2 to the power 2 is 4, so 3 is 8. So x is equals to 3. That is 1.1.4. Quite simple. It's not too bad. It's not too bad. This is easy, right? 5 easy marks. Right. And then 1.1.5, we have the square root of minus 2x plus 4 minus x being equals to 2. This is another basic one, right? We know exactly what we're going to do. We're going to isolate the square root here. We're going to be left with minus 2x plus 4 being equals to, well, let's just say x plus 2, because x is going to be positive when it goes to that side. And then we square both sides. Right? Sticking to the basics. When we do that, we get, let's say, minus 2x plus 4. I wanted to say 4 minus 2x, but it's fine. We can just leave it like that. And then x plus 2 squared, that is x squared plus 4x plus 4, right? Yes. Okay. I'm happy with that. So we're going to have x squared plus 4x plus 2x when we take it to the other side, right? So we get x squared plus 6x, and then 4 minus 4, that gives us 0. So we have x squared plus 6x being equals to 0. So take x as a common factor, we get x plus 6. This is equals to 0. So x is equals to 0, or x is equals to minus 6. Right, most of the time when we square, we introduce solutions that are not necessarily true for the equation when it is not squared. Let me show you, let me demonstrate what I'm talking about. So x is equals to 2. Well, what is x? X is 2. It's easy to see. We're saying that x is equals to 2. But take a look at this. If we square both sides, which is mathematically correct, we get x squared is equals to 4. But what are the solutions of x squared is equals to 4? X is equals to 2, or x is equals to minus 2. So when you square, you introduce things that might not be necessarily true for the original equation. So we need to test and see which one between these two it is not necessarily true. It is possible sometimes that they are both correct. Sometimes you can find a case like that, but let's test it out. Okay, so when I substitute 0, right, I'm substituting here, and after I substituted here, well, it's supposed to give me 2. So minus 2 multiplied by 0 plus 4 minus 0. This gives me 2. So x is equals to 0. It is working, right? Now let me substitute minus 6. So the square root of minus 2 multiplied by minus 6 plus 4 minus 6, right? Because that 6 is negative. And then here I get 10. 10 is equals to 2. Obviously 10 is not equals to 2. So x is equals to minus 6 is not necessarily true for the equation that we started with. That is 1.1.5. Let's take a look at 1.2. So here we have 2x plus y being equals to 3. Well, it's easy to see that our life will be easy if we make y the subject of the formula. If we do that, y is equals to 3 minus 2x. You can call this equation 1. You don't really have to do that, but yeah, you can do that. And then now we have x squared plus xy being equals to 2. This is our second equation. And then in place of y, we substitute 3 minus 2x. We square that, plus x 3 minus 2x is equals to 2. So let's solve 3 minus 2x squared. So this will give us, 4x squared minus 2x multiplied by 3, that is minus 6x. We multiply that by 2, minus 12x plus 9 plus 3x minus 2x squared. And this is all equals to 2. So 4x squared minus 2x squared, that is 2x squared, minus 12x plus 3x, that is minus 9x. And the 9 minus 2, right? That is plus 7. So if you forget these two here and you equate to 0, then yeah, it's not going to work out. And then this is equals to 0. Obviously, it is very difficult to factorize when we have a coefficient of 2, when the coefficient of x squared is 2. But if you find your way and you factorize, you should get 2x minus 7. And then here you have x minus 1. But it's always safe to use the quadratic formula. And then x is equals to 7 over 2, or x is equals to 1. Alright, so now we need to find the corresponding values of y. So when x is 7 over 2, what is the value of y? So 3 minus 2 multiplied by 7 over 2. I'm getting minus 4. So one possible value of y is minus 4. What about the case where x is equals to 1? So 3 minus 2 multiplied by 1, I think that just gives us 1. 3 minus 2 multiplied by 1, that gives us 1. So y is equals to 1. Okay, and then let's take a look at 1.3. I did post a video on a question like this not too long ago. So let's take a look. Determine all the values of n for which the product will be an integer value. Let's do that on a separate video. Here we go. So let me know in the comments which video you want me to do next. Right now I'm doing 1.3 and I'm going to upload it right now. But tell me, after 1.3, which question should we do next? 1.3 is a thing of beauty, and let me show you why that is the case. So consider the product 1 plus 1 over 2 multiplied by 1 plus 1 over 3, and lastly multiplied by 1 plus 1 over 4, so on and so on. Each factor in the product is of the form 1 plus 1 over n, for which n is greater or equals to 2, as we can clearly see from the first term that is the case. And then the question is saying determine all the values of n for which the product will be an integer value. Determine all the values of n for which the product will be an integer value. So this product as it is very hard to digest, but we can change it a bit. Let me show you in what way we can change it. So let me just drag these down and show you a couple of things. I want to drag these down. There we go. So instead of having 1 plus 1 over 2, let's just put that in our calculator. I get 3 over 2. So here the first term that I have is 3 over 2, right? And then let's move to the second term. 1 plus 1 over 3, that is 4 over 3. And then the third term, 1 plus 1 over 4, that is 5 over 4, right? 5 over 4. Let me rewrite that. So these are the terms of the product, not the terms of the sequence. Let me put it here so that I can show you something. And then this pattern goes up until 1 plus 1 over n, right? Of which we do not know. So the last term here that we have is 1 plus 1 over n. But we can do the same thing for that term. Well, not the same thing, but we can also rewrite that term. Let me show you how. 1 plus 1 over n. 1 plus 1 over n is the same as n plus 1 over n. Because if we give both those two terms on the numerator, a denominator of n would end up with 1 plus 1 over n. So instead of writing 1 plus 1 over n, we can write n plus 1 everything over n. But it does not end there. It does not end there. There's another layer of complexity that I want to introduce here. So that is the last term, right? For some n terms, right? That is the last term. So that is the last term. But I want us to think about the term that comes before this one. I want us to think about the term that comes before that one. So the term that comes before this one is supposed to be, so this is the last term. So I want us to concentrate on the term that comes before that one. The term that comes before that one, it should have a numerator of n minus 1, right? Plus 1, because it is the term that comes before n. So it must be n minus 1. So on the denominator also, we are supposed to have n minus 1. We are replacing n with n minus 1. So let's put that term together with the other terms. So we are saying that the first term is 3 over 2. 3 over 2. It is followed by 4 over 3. And then after that we have 5 over 4. And then we have some terms. Before the last term, n minus 1 plus 1 is just n, right? So we have n divided by n minus 1. And then after n divided by n minus 1, we have n plus 1 divided by n. That's what we have. So let me erase this and show you what happens here. You can see for the first 3 terms that 3 and 3 will cancel out, right? After that, 4 and 4 cancels out. 4 and 4 cancels out. If you were to add the fourth term there, you would see that 5 and 5 would cancel out. So ultimately, we are left with 1 over 2, right? After 3 and 3 cancels out, we are left with 1 over 2 up until these last 2 terms. But with the last 2 terms, n and n cancels out. That's easy to see that n and n cancels out. So we have some 1 over n minus 1, and lastly, the last term that we have is n plus 1, right? So that's what we're going to have. So let's see how these two terms behave. 1 over 2 and n plus 1. Let's see how they behave. We want the product to be an integer, right? An integer is a number that is not a fraction. It's a whole number, right? So when can these be whole? When can we multiply these two things and have a whole number? It's when n plus 1 is even. Because take a look at this. If n plus 1 is odd, we're going to have 3 over 2. And that is not whole, right? If n is odd, we're going to have 5 over 2. And that is not whole. But if n plus 1 is actually even, then we can have 4 over 2, which is 2, right? We can have 6 over 2, which is 2. So how can we achieve that? If n is equals to 3, our condition is satisfied, right? Because we're going to have 4 divided by 2. If n is equals to 5, we're going to have 6 divided by 2. If n is equals to 7, we're going to have 8 divided by 2. So on and so on. So n can be 3, 5, 7, 9, up until infinity, right? Some infinity odd number so that our product can be an integer. So there we go. Okay, let's take a look at 2.1.1. Calculate the sum of the series. So what information do we have? The first term of an arithmetic series is 7. So we are given that a is equals to 7. The common difference of this series is 5. So the common difference is equals to 5. And the series contains 20 terms. So we know that n is equals to 20. What are we looking for? We are looking for the sum. So we know fully well that the sum of some n terms is equals to n over 2 multiplied by 2a plus n minus 1 multiplied by the difference, right? So we're looking for the sum of the 20 terms. So S20 is equals to 20 over 2 multiplied by 2a. We know fully well that a is equals to 7 plus n minus 1. So 20 minus 1. The common difference is 5. So let me go ahead and put that in my calculator. So when I have 10 multiplied by 14 plus 19 multiplied by 5, this is equals to 1090. So the sum of the 20 terms is 1090. So this is 2.1.1. Let's take a look at 2.1.2. So 2.1.2, the original arithmetic series is extended to 75 terms. We now have 75 terms. Using sigma notation, write down an equation for the sum of the terms added to the original series. We need to be very perspicacious here. In 2.1.1, we determine that the sum of the first 20 terms is 1090, and then the sum of the 75 terms is 14,400. Let's pay attention to what we're looking for here so that we can make sure we don't miss anything. So listen to this. Use sigma notation and write down an equation for the sum of the terms added to the original series. The sum of the terms added to the original. So the sum added, we can find that by saying S75 minus S20, right? So 14,400, because you're looking for the sum of the terms that are added. Initially we had 1090 as our sum, and after we add some terms we have 14,400. So 14,400 minus 1090, this is equals to 13,310. This is the sum of the terms added, right? But we're not just looking for the sum of the terms added. We have to represent it using sigma notation. So from S20 to S75, we start with n being equals to 21, right? Up until n is equals to 75. So we know what number to start with at the bottom of our sigma and what number to put up there. And we actually know the sum, right? We know the sum of those terms that are added. Let's just call it SK. We know fully well that the sum is 13,310. So we have the number at the bottom, we have the number at the top, we have the sum itself, right? And then the equation Tn is equals to. So if we use the Tn for the original arithmetic sequence, A, we know fully well it is 7, right? And then plus, well, depending on what we're going to use, let's say K plus n minus 1. So let's say K minus 1 multiplied by the common difference, which is 5. So when we represent it, when we represent these as a sigma notation, we're going to have K is equals to 21, because that's where we start in, right? And then we end up when K is equals to 75. And the formula that we have, let me use a bra there and not a cat. It's 7 plus K minus 1, everything multiplied by 5. And we know that this sum should be 13,310. There we go. That is only 2.1.2. Let's take a look at 2.2 and 2.2.1. The sequence of the first differences of a quadratic pattern is 1, 3, 5. That is the sequence of the first differences of a quadratic. So that is arithmetic, right? And then 2.1.1, if T99 of this quadratic pattern is, so we have T99. It's 9,632. This is T99, right? The question says calculate the value of T98. So we're looking for T98. So let me put it here and say that we are looking for the value here, of which it is T98. We are looking for T98. Okay, so the difference between T99 and T88, we should be able to find it using this arithmetic, right? Because we know that this arithmetic, we find it from finding the differences of the quadratic. So we can use that arithmetic to find the number which we need to subtract here in order to find T98. Because from T98 to T99, we add a number there from a number here, right? From the quadratic, from the arithmetic, so that we can get the following term of the quadratic. So we just need to identify that number. But how do we identify that number? Let me show you something. So we have something like this. So T1 of the arithmetic is between T1 and T2 of the quadratic, and the T3 is between and the T2 is between T3 and T2, and the T3 is between T4 and T3. So we are looking for T98. So T98 should be the 98th, the difference between T98 and T99 of the quadratic should be T98 of the arithmetic. It should be T98 of the arithmetic, right? So we need to find T98 of the arithmetic and subtract it from T99 in order for us to find T98 of the quadratic. So T1 is 3, so A is equals to 1. The difference 3 minus 1, it's easy to see that it is 2. So we have, well, T98 rather being equals to A1 plus n minus 1. So we're looking for the 98th term. So we have 98 minus 1 multiplied by the difference, which is 2. Okay, so let me just put that in my calculator. So 1 plus 98 minus 1, everything multiplied by 2. So this is 195. So the term here that we have is 195. This is 195. So T98 is going to be 9632 minus 195 minus 195. This is 9 minus 195. This is equals to 9437. So there we go. This is T98. This is T98. Okay, there's another way to find T98, right? But another way that you can use to find T98, it involves finding Tn, which is what we are supposed to do in the last question, 2.2.2. So I don't know what is going to actually happen with that case, because in order for you to find T98, you can do that, but in doing that, you can find Tn first. But 2.2.2 says find Tn. So what do you do in that case? Because you've already found Tn in the question that came before. But anyway, stories, right? Let's do 2.2.2. We're supposed to find a Tn of the quadratic. We know fully well that Tn of the quadratic, it is an squared plus bn plus c. We need A, we need B, and we need C. How can we do that? So let's go back to our pattern, right, of the quadratic. We have T1, T2, T3, and T4. The difference between T2 and T1 is 1. The difference between T3 and T2 is 3. The difference between T4 and T3 is 5. We are getting that because we are given that quadratic, or that arithmetic pattern, right? And then the difference between 3 and 1 is 2. Obviously, the difference between 5 and 3 is 2. So already we can see that 2a is equal to the second common difference all the time, which is 2. So a is equal to 1 in this case. And then 3a plus b is equal to 1, right? So we have a. And then 3a plus b, so we have 3 plus b being equal to 1. So b is equal to minus 2. So we have b. So now we need to find c, right? We can say a plus b plus c is equal to t1. But the problem is that we don't have t1. But we have t99 because it is given to us. So we can say that t99 is equal to a is 1. And then n is 99. So 99 squared minus 2 because b is minus 2, and then n is 99, and then plus c. But we do have t99. T99 is 9632. So let's replace that with 9632. So c is equal to 9300 or 9600. 9632 minus 99 squared plus 2 multiplied by 99. Okay, so let me put that in my calculator and find c. So 9632 minus 99 squared plus 2 multiplied by 99. This is 29. So c is equals to 29. So we have tn being equals to n squared minus 2n plus 29. So this is tn. Obviously, we can test and see if this is correct, right? We can substitute 98 and substitute 99 and see if we're gonna find. When we substitute 99, we shall find this term, and then when we substitute 98, we shall find the term that we found as an answer to the previous question. So let's substitute 99. So 99 squared minus 2 multiplied by 99 plus 27 gives us 9630. Yeah, that is because I said 27 instead of 29. Yeah, so let me put 29 in my calculator. 9632. So T9 is correct. I'm quite confident that Tn as a whole is also correct. There we go. Okay, we've done question 1, we've done question 2. Now I'm doing question 3. Tell me which question you want to see next. Do we just go to 4, 5, 6 up until 12, or should we jump to one specific question that you had the problems when you were doing today in the exam? Let me know in the comments. But nevertheless, let's take a look at 3.1. Write down the radius of the third circle. Let's take a look at the information that we have. A circle with radius 6 centimeter is drawn. A second smaller circle is drawn through the center of the first circle and also touches the first circle internally, as shown in the diagram. A third smaller circle is drawn through the center of the second circle and touches the second circle internally. The process of drawing circles continues and forms a geometric pattern. Okay, so that is what we have. They form a geometric pattern. Back to our equation. What does it say? Write down the radius of the third circle, and that is for 2 marks. Okay, we can do it the easy way, conceptualizing. Let's go ahead and take a look at that. So we know fully well that the radius of the biggest circle is 6, right? So we have 6 there, and we have 6 right there. So that is also 6, okay? And then let's take a look at the second smaller circle. The second smaller circle should therefore have a radius of 3, right? We're going to have 3 here, and then we're going to have 3 there. And then now let's come to the smaller circle. So the smaller circle, it has a diameter of 3. So the radius, let me just put a dot here. Oh, that is too big. So maybe this is gonna work. No, also too big. So the radius of the smallest circle, that is the center, right, should be 3 over 2 that side, right? And this side we also have 3 over 2. So that is the radius of the smallest circle is 3 over 2. So the answer to 3.1, 3 over 2. This is the answer to 3.1. How are we getting to 3 over 2? The radius of the biggest circle is 6. The radius of the circle that follows is 3. And the radius of the third circle is 3 over 2. Right, we can clearly see that we have 6. And then here we're going to have 6 as the diameter and 3 as the radius. Here we're going to have 3 as the diameter and 3 over 2 as the radius. So there we go. And then 3.2, calculate the sum of the areas of the first 10 circles. And that is for 4 marks. Calculate the sum of the areas of the first 10 circles. Well, honestly speaking, I don't think this question should be for 4 marks, right? Because I think there's a lot of dots that we need to connect in order to answer this question. So calculate the sum of the areas of the first 10 circles. So let's think about this. The sum, let's say sum of A, right? The sum of the areas is going to be pi r squared, right, for the first circle, plus pi r squared for the second circle, plus pi r squared up until some last pi r squared. Okay, because we're looking for the sum of the areas of the first 10 circles. Okay, right. So this is what we have. Obviously the radius, the first radius is going to be of the first circle, and then the second circle, and then the third circle. So how are we going to be able to do this? You calculate the areas of one circle at a time up until 10. That doesn't seem very efficient, right? Take a look at this. We can say that the sum of the areas of these circles is equals to, let's take pi as a common factor. Let's take pi as a common factor. So we're going to have r1 squared plus r2 squared up until the 10th circle. So we're going to have r10 squared. So what can we do? We can use a bit of math to find the sum here. We can use a bit of math to find the sum right there. But then you need to realize something, that r squared is not r, right? So we need to take this pattern that we are seeing from the radius of the circles and form r squared as a pattern. Okay, so when we looking at the sequence that is made up of the radius squared of the circles, the first radius should be 6 squared, right? And then the second radius should be 3 squared, and then the third therefore should be 3 over 2 squared, so on and so on up until the last circle, r10. Okay, so this is the sequence, so to say, that is formed by the radiuses of these circles, right? The radiuses squared, because that's what we are now interested in as we attempt to find the areas of these circles. Okay, so 6 squared, obviously that is 36, and then 3 squared, that is 9, but no need to worry about that. We just need to realize that A, the first radius, is 6 squared, right? The first radius squared. And then r, we need to distinguish this r. This r is not the radius, but rather the ratio, right? Because we know that we have Tn is equals to AR to the power n minus 1. This r is not the radius, it's the ratio. So don't confuse it with the two, with the radius. This is actually the ratio. So the ratio is equals to T2 divided by T1. So we're going to have 3 to the power 2, 6 over 2. So this is 9 over 36. So this is A, this is the radius, and then let's find the sum, right, of the first 10 terms of this sequence, of this series, because we are talking about the sum. So to find the sum, we have Sn being equals to, well, let me take my question paper and look at the formula, right? Don't want to make any mistakes here. So the sum of some n terms in our formula sheet is given as a r to the n minus 1, everything divided by r minus 1. That's what we're given. So the sum of the first 10 terms, we're going to have a being equals to 6 to the power 2. So we have 6 to the power 2. And then we have r being 9 over 36, and then this is to the power 10. We subtract 1 and we divide everything by r minus 1. So that is 10 minus 1. So I just need to put that in my calculator. So 6 squared multiplied by, well, 6 squared, that's 36, multiplied by 9 over 36, everything to the power 10, minus 1 divided by 10 minus 1. I'm getting, let me just verify that I'm doing the right thing. So the first term is 36, okay, and then that is followed by, okay, here I have r minus 1. I substituted 10 there, which is wrong, right? It's not n minus 1, but r minus 1. I was getting a negative number, so I was getting surprised. So r is 9 over 36, and then we subtract 1, okay, and then the answer is 47. So S10 is 47.99995. Okay, and then let me open the instructions on the question paper and see if I can round off to 2 decimal places. Answer all the questions, number the questions correctly. If necessary, round off to 2 decimal places unless stated otherwise. Okay, so I can round off to 2 decimal places, right? So that is S10. That is this entire thing. That is this entire thing. So the sum of the areas is going to be equals to pi multiplied by 47.99995. So this is just 47.99995 pi, of which when you round off to 2 decimal places like we can, we get 48 pi. So the sum of the areas, some units squared. Yeah, are we given the units? No. Oh yes, we're given centimeters actually. So centimeter squared. So there we go. That is the sum of the areas. I know there's somebody who got 48, but forgot to include centimeter squared. Yeah, there has to be somebody who, made that mistake. But anyway, sorry, that is 3.2. Let's take a look at 3.3. So 3.3, which circle has a diameter of 3 over 128? So this is the diameter, right? Diameter is equals to 2r. We're interested in r. We've been talking about r here throughout. So let's go ahead and find r. So r is going to be 3 divided by 128, everything divided by 2. So 3 divided by 128, everything divided by 2. I'm getting 3 divided by 256. So which circle has a radius of 3 divided by 256? We have to go back to this sequence that is made up of the radiuses, right? Because the first radius is 6 followed by 3 followed by 3 over 2, right? And we know fully well that Tn is equals to ARn minus 1. So Tn, we're looking for a radius which is 3 over 256. A is the first term, 6. R is 3 over 6, which is 1 over 2, right? Yeah. So we have 1 over 2 to the power n minus 1. So we're looking for minus 1 here. So from the get-go, we can just divide both sides by 6. So I'm getting 1 over 2 n minus 1 being equals to 1 over 512. Okay, so I can just introduce log on both sides here. I get n minus 1 log of a half being equals to log of 1 over 512. So obviously I'm gonna get n being equals to log of 512 with a base of a half when I divide by log on both sides, and plus 1 when I take 1 to the other side. So let me just substitute that in my calculator. Where is log? Here where I can write a base. It's running away from me, so let me just use log as it is. So I have a log of 1 divided by 512 divided by log of 1 over 2 plus 1, yes, and then I'm getting 10, n is equals to 10. So which circle has a diameter of 3 over 128 centimeters? The 10th circle, the 10th, yeah, something like that, but n is equals to 10. There we go. Question 3. Which question should I do next? Let me know in the comments. Calculate the value of a. It will not be p power 1 if there is no such equation. Calculating the value of a when we are given a function. So let's go ahead and take a look. F of x is equals to a to the power x minus 1. And we are given a point b which lies on the function f of x. We have 2 for the x value and minus 5 over 9 for the y. It's quite easy to see what we need to do. In place of x, we sub 2. In place of y, minus 5 over 9. So we're going to have minus 5 over 9 being equals to a to the power 2 minus 1. So a to the power 2 is equals to minus 5 over 9 plus 1, which is equals to 4 over 9. So should be easy to see here that a to the power, well, let's just say a to the power 2, everything to the power a half, and then 4 to the power 4 divided by 9, everything to the power a half. 2 and 2 cancels out. We have a being equals to 2 over 3, right? Because 4 to the power a half is 2, 9 to the power a half is 3. So a is equals to 2 over 3. So at this point, we know that f of x is equals to 2 over 3 to the power x minus 1. That is 4.1. Let's take a look at 4.2. So 4.2, we're supposed to write down the range of f. Well, f of x, again, it is equals to 2 over 3 to the power x minus 1. So let's talk about this. Let's talk about this right here. So the first thing that we need to realize is that this part can never be equals to 0. That part can never be equals to 0. If it cannot be equals to 0 and it cannot be negative also, it means that y will always be greater than minus 1. Because for y to be equals to minus 1, we need this part to be equals to 0, and we know that that cannot happen, and that part can also not be negative, so we know that we cannot have a value of y which is less than minus 1. So all values of y, we have y being greater than minus 1, so that is the range, right? And then 4.3, right, well, not right, but sketch the graph of f. Clearly show the intercepts with the axis and asymptotes, if any. So our first asymptote, y is equals to minus 1. We are not supposed to touch this line, because in order for us to touch that line, we would need 2 over 3 to the power x to be equals to 0. And we know that that cannot happen. So that is one asymptote. And then values of x, do you have a, because this is the horizontal asymptote, do we have a vertical asymptote? No, I don't think we have a vertical asymptote. It seems like f of x is defined for all values of x. And then the intercepts, well, let's let x be equals to 0 and see what the value of y is. So a to the power 0, well, we have the value of a, but it doesn't really matter. A to the power 0 minus 1, so we have 1 minus 1, which is 0, because any number to the power 0 is 1, except for 0, right? And we know that a is not 0, it's 2 over 3. So this is the intercept. We have 0 and 0. So serves as the x, serves as the y. So we are good to go here. Now we just need our axis. So our axis, this is, well, what am I doing? This is the y, and this is the x, right? And then our asymptote, our horizontal asymptote is at y is equals to minus 1. So this is our asymptote. We are not supposed to go beyond that line. We're not supposed to touch that line. We get very close to it, but we actually never touch it. So that is x, that is y. And then we have our intercept right here. So how is our graph going to look like? It's going to look like this. So if this is what you wrote in the exam, unfortunately, this is wrong. This is wrong. This cannot be. This cannot be. This is actually very wrong. You will see why it is wrong when you do 4.4, because initially I had drawn it like this, but then in doing 4.4 I realized that no, wait a minute, this is actually wrong. So our graph is actually supposed to face the other way, right? Supposed to be greater when x is negative rather than when it is positive. So this is what it actually needs to look like. You will see why that is the case when we do the second question. So let's just do that. Here we have x is equals to, well, y is equals to -1. So let's do 4.4 so that I can show you what I'm talking about. It is further given that C is a point on f at y is equals to 19/8, right? And then the question, determine the coordinates of C prime, the image of C when C is reflected about the line y is equals to x. So that reflection, if we have AB, right, and we reflect about the line y is equals to x, we have BA, right? They just sort of interchange. So this is the reflection that we need to talk about. But we are only given the value of y. So it is up to us to find the value of x. So f of x is equals to a is how much again? 2/3, 4, 9. Okay, 2/3, right? So 2/3 to the power x minus 1, right? We have the value of y, which is 19/8, and then we are looking for the value of x, 2/3 x minus 1. So let's take -1 to the other side. So 19/8 plus 1 is 27/8. So we have 2/3 to the power x being equals to 27/8. So x is equals to log of 27/8 with a base of 2/3, right? So we introduce log on both sides, we drop the x, becomes a coefficient of log of 2/3, and we divide both sides by log of 2/3. We end up with that. So x is equals to, so let me go ahead and put that in my calculator. So yeah, yes, log. The base is 2/3 and the number is 27/8. So x is equals to -3. This is the point. -3 is the value of x. 19/8 is the value of y. We're supposed to reflect this point about y is equals to x. So first of all, let me show you what I was talking about when I said that the way that you do 4.3, it has to look like this rather than looking like this. Yeah, it becomes apparent when we do 4.4, because this point x is -3, right? So x is -3 somewhere. What am I doing? X equals to 3 -3 is somewhere here, and then 19/8 is 2.37. So somewhere here, right? So that is the coordinate. This is the coordinate C. That is the coordinate C. But if your graph is somewhere here, then x -3 would be negative. And when x is equals to -3, y would be negative. And you can see that that is actually not supposed to be the case. So yeah, in doing 4.4, if you made a mistake in 4.3, you should be able to realize. So when we reflect this, so this is C. So C prime should be 19/8. And then y is -3. There we go. So let me know in the comments, which video should I do next? We've done 1, 2, 3, 4. If you have not watched those videos, please subscribe, go to the channel and find those videos. But let me know, which video should I do next? Which question? Here we go. You just have to forgive me for the way this question looks. I know it is a bit skewed and so on, but I'm trying to save time. I'm trying to do these questions as fast as I can, okay? But anyway, stories. Let's take a look at 5.1. Write down the value of P. So what are we dealing with here? We have f of x, which is equals to a divided by x plus p plus q, right? And then in order for us to find I have to think about this. To find the vertical asymptote, we have to say that x plus p is equals to 0. So x is equals to minus p. This is how we find the vertical asymptote. Okay, so let's take a look at our graph and see if we can determine our asymptotes. We can see the vertical asymptote here, that x is equals to 1. That is the vertical asymptote. So what does that tell us? This tells us that when x is equals to 1, we have the vertical asymptote. Okay, we're back in business. X is equals to 1. So it should be easy to see that p is equals to minus 1. But let's see if this brings us back to the vertical asymptote being equals to 1. So we would have x minus 1 being equals to 0, x is equals to 1. So it's easy to see that indeed the vertical asymptote is equals to indeed p is equals to minus 1. Okay, and then 5.2, determine the equation of the horizontal asymptote. Determine the equation of the horizontal asymptote. The horizontal asymptote, we are looking for the value of q. That is the horizontal asymptote. Q is right here. We are looking for q. That is the horizontal asymptote. So how are we going to do that? We don't have f of x, right? And then we don't have any number that is given close to the vertical asymptote, like we were given in the vertical, close to the horizontal asymptote, just as we were given on the vertical asymptote. So how are we going to do that? Well, we are going to use the equation of the line of symmetry, right? We know that g of x is equals to x minus 3. Okay, g of x is equals to x minus 3. And our asymptotes p and q. P and q, they meet at not p but minus p. Minus p and q. Minus p and q. We know fully well that they meet right here at that point. They meet on the line of symmetry. So we can actually substitute the value of p in order to find the value of q, because the value of p is going to be our x and the value of q is going to be y. So we have q being what we're interested in, and then in place of x we have 1, right? Minus p, minus 3. So q is equals to minus 2, right? So we can conclude here and say that our horizontal asymptote, we have y being equals to minus 2. This is what you need. Y is equals to minus 2, not q is equals to minus 2. I've seen this get marked wrong, right? On I think it was the prelim in Gauteng. So, you're not supposed to end with q is equals to minus 2. You're actually supposed to go further and say y is equals to minus 2. We are not looking for the value of q. We're looking for the equation of the horizontal asymptote. Y is equals to minus 2. So there we go. Right, very basic things, but with just a bit of a twist, really. Yeah, they're very basic, but there's a twist. So I would expect this question to throw some people off. But anyway, stories. Let's take a look at 5.3. So 5.3, we are looking for the value of a, right? We know that f of x is equals to a divided by x plus p plus q. We're looking for a. We have p and q, so let's just sub them in our equation. F of x is equals to a divided by x plus p, so x p is minus 1, so x minus 1, and then q is minus 2, and then minus 2, right? And then x minus 1 is equals to 0, x is equals to 1, so we have the asymptote there. Okay, I was just checking if I'm substituting them in the correct way. So this is f of x as we have it. We need to substitute a point into f of x so that we can find the value of a. That's what I'm thinking. There might be another approach, but that's what I'm thinking. So let's see if we have a point here. Do we have a point we can substitute into f of x? Let's take a look. There has to be something we can substitute here. the graph of f casts the x-axis, or not the x but the y-axis, at 0 and 1. So okay, we know that this point lies on f of x, so we can substitute it. In place of y we have 1, right? And then in place, let me see, in place of a, that's what we're looking for. In place of x we have 0, right? I thought x is minus 1. Issues were gonna arise there. I was not quite happy with that. So a divided by 0 minus 1 minus 2. So we have 1 being equals to a minus 1 minus 2. We take minus 2 to the left hand side. We get 3 is equals to a divided by minus 1. A is equals to minus 3. I think we can just end it there. A is equals to minus 3. But let's just go ahead and see if it makes sense. A is minus 3, x minus 1 minus 2, I think. X minus 1 minus 2. So let's substitute 0 and see if we get 1. Yeah, when we substitute 0, we get 1. So I'm quite convinced that that is the correct value of A. And then 5.4, for which values of x is f of x greater or equals to 0. So let's take a look at this wing here. When we take a look at that wing, f of x greater or equals to 0. Well, it is less than there. It is less than. It is less than. Because that is below the x-axis, right? Because we have the x-axis right here. So that wing is below the x-axis. So it cannot be part of our solution because it is always negative up to infinity. Okay. And then let's look at this other wing. The other wing, well, when does it become positive? We need to find values for which it becomes positive. Is that easy to find? We just know here that we have 0 and 1. So it becomes positive somewhere here, right? That's where it becomes positive. But we don't have the x value at that point. So I think we I think that we need to actually find the value of x for which it becomes it starts becoming positive, right? So how are we gonna do that? Well, what is the value of x when y is equals to 0? Okay, so that's the question. Let's take a look. F of x, we need it to be equals to 0. So we have 0 being equals to minus 3 divided by x minus 1 minus 2. So 2 is equals to minus 3 divided by x minus 1. Okay, so 2x minus 2 is equals to minus 3. So 2x is equals to minus 1. So x is equals to minus 1 over 2. So the value of x here at this point where it starts becoming positive is minus 1 over 2. So from minus 1 over 2 up until x gets very close to positive 1, our condition is satisfied, right? Our graph is gonna be greater than 0. Is that what we're looking for? Yeah, we're looking for the values of x for which f of x is greater than 0. So we need x to be, it says greater or equals to, so we can include minus 1 over 2, but we cannot include 1 because it is not defined at 1, right? We just get very close to 1, but it is actually not defined. So why am I using a bra and not a cat? We're supposed to write this one. Okay, so there we go. That is 5.4. And then what about 5.5? What about 5.5? I'll let you guys talk about it in the comments. What about 5.5? What about 5.5? I want to hear what you guys think. But ultimately, describe a possible transformation that f could have undergone to result in h. What is the characteristic of h? The domain and range of h are the same as that of f. Okay, and then h prime of x, the derivative of h is negative on its domain. So what is the possible transformation? Let me know in the comments. But should I give the answer? Okay, I have the answer in front of me, but I feel like if I give the answer, then it is no longer fun. So I'll let you guys talk about it in the comments. And then, after a couple of comments, 20, 30 comments. Yeah, give me 30 comments. And then I will sort of give you the answer to 5.5. Yeah, there we go. Which question do we do next? We've done 1 to 6. Do we just do 7, 8, 9, 10, 11, 12? Let me know in the comments. Calculate the coordinates of B, the turning point of F. We're given that f of x is equals to minus x squared plus 4x plus 5. So we want the coordinates of B, the turning point. What do we know about the turning point? We know fully well that the gradient at the turning point is equals to 0. So we can find f prime of x, of which this is going to be equals to minus 2x plus 4. And then we equate these to 0, right? So should be easy to see that minus 2x is equals to minus 4, x is equals to 2. That is the x value of B. Now let's go ahead and find the y value of B. So we substitute 2 into f of x, not f prime of x, but actually f of x. So we're going to have minus 2 squared plus 4 multiplied by 2 plus 5. So let me just go ahead and put this in my calculator. Minus 2, and then we square that. The minus is on the outside. I didn't put it inside. Don't worry about that. Plus 5. And then I'm getting the y value to be equals to 9. So the coordinates of B, x is 2, y is 9. Okay, let's take a look at 6.2. So 6.2 show that the equation of the line through A and C is given by g of x is equals to 2x plus 2. Okay, let's take a look at this. G of x. So g of x is a straight line, right? And then the point C is a point of intersection of f and g, which is right here. So this point lies on g of x. Does A also lie on g of x? Let's just go through the entire question statement. So the question says show that the equation of the line through A and C. Okay, so the line passes through A and then it passes through C. In order for us to find the gradient, we have the coordinates of C, which happens to be 3 and 8. So in order for us to find the gradient, we need to some way somehow find the coordinates of A, right? Which we can just factorize f of x. We can just factorize f of x, and then in doing that, we will have what do we call this? We will have the values of A. Unless if there's another way of doing it. Is there another way of doing it? I cannot see an immediate way of doing it. But if there is, we can also explore that way. But here I can see that if I let minus x squared plus 4x plus 5 to be equals to 0, I can find the x value of A and the x value of D and be able to substitute it into what do we call this? And substitute it into f of x. Okay, so let's go ahead and see. So here, if we divide both sides by minus 1, we get x squared minus 4x plus 5. No, minus 5 is equals to 0. So x factors of minus 5, when you add, we get minus 4 minus 5 plus 1. This is equals to 0. So x is equals to 5 or x is equals to minus 1. It should be easy to see that x is equals to minus 1 is the x value at A, right? So x is equals to minus 1 is our x value at A. Okay, so there we go. We have A. A has coordinates minus 1 and 0. And C has coordinates 3 and 8. So let's go ahead and find the gradient. Y2 minus y1 divided by x2 minus x1. So if we take C as the second point, y2 is gonna be 8, right? And then y1 is 0. And then x2 is gonna be 3, x1 is gonna be minus 1. So 8 divided by 4, that is 2, right? So we know now that the g of x is equals to 2x plus some c. In order to find c, we can substitute either a or c, right? Let's substitute a. A has coordinates minus 1 and 0. So when x is equals to minus 1, y is 0. So 0 is equals to 2 minus 1 plus c 2 is equals to c, g of x is equals to 2x plus c. Okay, let me just tell you what the problem I have with this question. We got g of x is equals to 2x plus 2, not c, 2x plus 2. And we are quite happy with that. We are convinced that what we have done is correct. But take a look at this. In the diagram below, the graphs of f of x and g of x, a straight line, are drawn. C is the point of intersection of f and g. E is drawn parallel to the x-axis. And E, a point on f and h, are on g. Right. E, a point on f and h. Oh, okay. A point on g. Okay, I see that. But take a look at A. We are now told that A is an x-intercept. And nothing is being said about D. I was supposed to just look at it and conclude ourselves that those are x-intercepts. I mean, nothing here in the question says that they are x-intercepts. But in order to find the equation of g of x, we have to take A as the x-intercept. But it is not said. So do we just look at it and say, oh, well, it's close to the x-axis, so it's the x-intercept? Is that what we're supposed to do? Is that mathematical? No, it is not. More especially if we are always told that, I can see point 8 here on the question paper, diagrams are not necessarily drawn to scale. So why am I now supposed to conclude that A is an x-intercept when I'm not being told? Or when it is not shown in some way hidden or clear? So, not a fan of 6.2. I don't think it's a good question. I'm criticizing the examiner here. But anyway, so it is 6.2. Let's take a look at 6.3. Calculate the maximum length of EH for f is greater than g. A basic equation that we always see. So EH is going to be f of x as it is at the top minus g of x, which is below it, right? So in place of f of x, we have f of x. What else are we going to have? But anyway, minus x squared plus 4x plus 5. And then we subtract g of x, which is 2x plus 2, okay? And then this is going to give us EH is going to be equals to minus x squared, it does not have a like term, and then plus 4x minus 2x, that is plus 2x plus 5 minus 2, that is plus 3. So this is EH. We are looking for... What are we looking for? We are looking for the maximum length, right? So we can already see that EH is a parabola, which is said it looks like something like this. So essentially, we're just looking for the turning point there. So we can derivate and equate to 0, or we can say x is equals to minus b divided by 2a. We can also do this. It's gonna allow us to find the value of x at the turning point. So this is minus 2a is minus 1. So is x equals to 1? It seems like that is the case. And then now let's substitute this value of x into EH. So EH is equals to minus 1 squared plus 2 multiplied by 1 plus 3. So we have, we have minus 1 because the minus is on the outside. So minus 1 plus 2, that is 1 plus 3. And then we get 4. So there we go. It seems like EH is a maximum when it is equals to 4. That is the maximum value of EH. Okay, 6.3. Let's take a look at 6.4. So we need to, think just a bit. 5 marks. Let's see what is happening. Given that k of x is equals to f of x plus m, and it is ultimately equals to minus x squared minus 2mx minus m squared plus 4x plus 4m. That is a lot. Let me erase that and write it again so that it can fit in the screen, because it seems like there's a lot happening here. So k of x is equals to minus x squared minus 2mx minus m squared plus 4x plus 4m plus 5. If I sound animated, I'm high on caffeine, so I'm all over the show now, starting to get tired, but let's keep going. Determine the value of m such that g is a tangent. Determine the value of m such that g is a tangent. So g of x is a tangent. G of x is equals to 2x plus 2. So the first thing that we're going to do here we're going to say that k of x is equals to g of x. That is the first thing that we're gonna do. K of x is equals to g of x. Why are we equating these two? Because in order for g of x to be a tangent, you can agree with me that k of x and g of x need to touch, right? But the special condition is that they need to touch only once. So we are gonna address that. First of all, let's just address k of x being equals to g of x, because we know that that needs to be true. So let's go and see what we end up with. So k of x is equals to g of x. What does that give us? Minus x squared. Well, let me just copy k of x already because I have it, because it's quite long. I don't want to rewrite it. So this is k of x, and I want to duplicate it and put it here, and then I equate to g of x, which is 2x plus 2. So 2x plus 2. Okay, so I'm going to take 2x to the left hand side, obviously. So I'm going to have minus x squared minus 2mx, and then minus m squared plus 4x minus 2x, that will be plus 2x, and then plus 4m plus 5 minus 2 plus 3. This is equals to 0 when we take that to that side. Okay, so let's just rewrite this in a more acceptable form. Let me show you what I'm talking about when I say in a more acceptable form. So minus x squared. That is the only thing with x squared here, right? Okay, yeah, it seems. So let's find the things with a coefficient of x. Those are the two. So minus 2mx plus 2x. And let's find, and then here I'm just writing minus m squared plus 4m plus 3 being equals to 0. So this is the equation that we have. We can still, simplify that further. Let's do that. Minus x squared, and then minus, I want to take x as a common factor from these two terms. I want to take x as a common factor. So let me say plus x, and then I'm gonna have minus 2m plus 2, right? And then this right here is just a constant, right? So we have minus plus, let's say plus, minus m squared plus 4m plus 3 being equals to 0. So this is A, this is B, this is C. All right, so we need to find the discriminant of that. We need to find that thing, that delta, which is equals to b squared minus 4ac. Why do we need this delta? Because when this delta is equals to 0, g of x and k of x only touch once. When that thing is equals to 0, they only touch once. That is very important to realize, that when that thing is equals to 0, they only touch once. Okay, so b squared, that is going to be minus 2m plus 2 squared, and then minus 4. A is minus 1, and C is minus m squared plus 4m plus 3. There we go. So minus 2m plus 2 squared, that is going to give us 4m squared minus 8m plus 4. Okay, so I've just solved what is inside the brackets there. Yeah, I'm underlining here so that I can not lose track. And then minus 4 plus multiplied by minus 1, that will be plus 4, right? And then what about these? Okay, that is just that. That is m squared. Well, not m squared, but minus m squared. That is minus m squared plus 4m plus 3. Okay, and then this is equals to 0. So my 4m squared minus 8m plus 4 minus 4m squared plus 4 multiplied by plus 4m plus 8m plus 12 is equals to 0. So 4m squared minus 4m squared, that gives us 0. And then minus 8m plus 8m, that also gives us 0. And then 4 plus 12, that is 16. So we get 16 is equals to 0. Okay, I think the issue might lie here. Okay, because m cannot be 0. Well, it can't be 0 because the question just says determine the value of m. But let's re-evaluate these. Let's take a look at these once more. So, shouldn't have erased that. Let me just erase some of it and not all of it. So let me erase, and then yeah, this right here is this part. This right here is this part. So let me do this part, minus 4ac, right? So I have minus, let me erase this. No, I don't want to erase the entire thing. Let me show you what I want to do. So I want to drag these. And say minus 4ac. So I want to find the 4ac separately, right? So I have minus, and then I have my 4 right here, and then I want to solve that, which is inside the brackets there. So when I solve that, obviously I can start out by multiplying with 4, right? And then not 4 but minus 1. So I'll get 4, and then m squared plus, not plus but minus 4m, minus 4m plus 3, right? Plus 3 or minus 3, minus 3 actually, minus 3. Okay, so that is minus 3, and then this is equals to 0. So 4m squared, we will get, okay, I'm still solving what is inside the brackets there. So 4m squared minus 8m plus 4 minus what is inside the bracket. Inside the brackets I have 4m squared plus, not plus but minus 8, no, 4 multiplied by 4 is 16. So I think that is where the issue was arising. It is 16 minus 16m. Now I see where the problem was. Minus 12. Damn it. Almost lost it there. So 4m squared minus 4m squared, that is 0. And then minus 8m minus 16m. That is going to give us plus 8m. And then plus 4 minus 12. So 4 plus 12, that is 16. This is equals to 0, it seems. So 8m is equals to 16. So m is equals to minus 2. M is equals to minus 2. Okay, I see what the problem was. You know, sometimes you do the right thing, you just make one small algebra mistake and you're gone. But let's test and see if it is actually correct, because I'm going to have people in the comments saying, no, it is not correct, this is the correct way, blah, 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 I did this, I did that. Send us your solution. Don't just give us your opinion, send us your solution. Let's take a look at your work. Right, so k of x will now be equals to, because we are saying that m is minus 2, k of x is going to be equals to minus x squared, right? And then minus 2 minus 2, that is the value of m, x, right here it is, and then minus m squared, so that is minus 2 squared, plus 4x plus 4m, m is minus 2, plus 5. So k of x is equals to minus x squared plus 4x, and then this is going to give us 4, and then we're going to have minus 4 plus 4x minus 8 plus 5. Okay, so kx squared is minus x squared plus minus here plus 8x. So minus 4 minus 8 plus 5, that is minus 7. Minus x squared plus 8x minus 7. So this is k of x, and then g of x is equals to 2x plus 2. Okay, so these two things, they must touch once. So how can we prove that they actually touch once? Let's equate them and see if we get one solution. So minus x squared plus 8x minus 7 is equals to 2x plus 2. So minus x squared plus 6x minus 9 is equals to 0. I'm giving myself a very unnecessary headache. Okay, so okay, fine. So x squared minus 6x plus 9 is equals to 0. I just divided both sides by minus 1. So that is mathematically correct. So let's see if the discriminant here is going to have is going to be equals to 0. Okay, so that delta b squared minus 4ac. So b squared, that is minus 6 squared, minus 4, a is 1 and c is 9. So this is 36. And then 9, 18, 36. This is 36 also. So this gives us 0. So the discriminant is actually 0. So I'm quite convinced that we have finally done, we finally determined the correct value of m. Okay, so there we go. Which video do you want me to do next? Okay, let's take a look at 8.1.1. We have d over dx of 3x minus 5x squared. We can simply use the power rule here, right, to determine that, of which we're going to get 3 minus 10x. No complications there. We're just using the power rule. And then taking a look at 8.1.2, we're supposed to find g prime of x when g of x is equals to 2 over x squared minus 3, and then we have the square root of x to the 7. So a few issues might arise here. We are not able to use the power rule when our function looks like that. So what do? We just rewrite it. We don't have to really complicate things. What do I mean by that? Let me show you. So we're gonna have, for the first part, g of x is equals to 2 multiplied by x to the minus 2. When you bring x squared to the numerator, the power changes sign, right? And then we're gonna have minus x to the 7 over 3. So when we have written it like this, we can then derivate, and then we are able to see g prime of x. We cannot say g prime of x at this step, it would be wrong. We say it on the last step. So this will be equals to minus 4x minus 3, right? And then minus 7 over 3 x to the 7 over 3 minus 1. So 7 over 3 minus 1, 4 over 3. So 4 over 3. So g prime of x is minus 4 divided by x to the power 3 minus 7 over 3 x to the 4 over 3. So I think we can leave it like that. I don't think yeah, we can be required to further simplify it. I think that is perfectly fine. And then 8.2, determine the equation of the tangent to f of x at x is equals to 2. So f of x is equals to x to the power 3 minus 4x squared plus 2x plus 3. When we derivate this, right, we are going to have 3x squared minus 8x plus 2. And then we substitute 2. So f prime of 2 is equals to 3 multiplied by 2 squared minus 8 multiplied by 2 plus 2. And I think this is minus 2. So that is 8.2. And then 8.3.1, we're supposed to find f prime of x using first principles. If f of x is equals to minus 6x squared. So I'm not going to do this one just for the sake of time. But ultimately, the answer we should get, f prime of x is equals to minus 12x. Right. This will be f prime of x. But you're supposed to use the first principles. You can see the mark allocation is 5. Easy marks, really. Free marks. The mark allocation is 5. But you're supposed to use the power rule. You're not supposed to... you're supposed to use first principle, not the power rule. The power rule just helps you to see if you've done the correct thing. And then 8.3.2, Write down how you will restrict the domain of f such that f inverse, the inverse of f is a function. Okay, in order for me to explain this, I will also be answering 8.3.3 in the same way. Let me show you why. Okay, so y is equals to minus 6x squared, right? So the inverse is x is equals to minus 6y squared. So we end up with y squared being equals to x divided by minus 6. So y is equals to plus or minus x divided by minus 6. So you can see that we need values of x to be negative here. We need values of x to be negative because when values of x are negative, it ensures that the square root is defined. Because if x is positive, it's not going to be defined because we cannot take the square root of a negative number. So we need x to be positive here. We need x to be greater than 0. So this is the restriction we can impose. We need x to be greater than 0 because when x is greater than 0, the square root is going to be defined. If it is 0, it is undefined. If it is negative, it is. And well, we don't need it to be greater than 0. We need it to be less than 0. We need x to be less than 0. Because if x is positive, let's say 2 for instance, when I have 2 divided by minus 6, which is minus 1 over 3, and that is going to be undefined because it is under the square root. So we need x to be less than 0. For instance, minus 6. We're going to have minus 6 divided by minus 6, which is 1, and that is 5. So, okay, there we go. We need x to be less than 0, not greater than. Okay, 8.3.3. Determine the equation of f inverse for which f inverse is less or equals to 0. Write your answer in the form y is equals to. So you can see we have a plus or minus. If we need it to be less than 0, this is the option that we need to take. F inverse of x is equals to minus the square root of x divided by minus 6. Here we go. For which values of x is f decreasing? For which values of x is f decreasing? So we look at our function from left to right, right? We're not from right to left. Let me show you what I'm emphasizing, that from here going there, x is not decreasing, right? Because we look at it from left to right, we actually have to go that way in order to see whether it is decreasing or increasing. So here x is, well, not x but f is increasing. It decreases until it reaches a, which is a stationary point, right? A and b are the turning points. It is neither increasing nor decreasing at a and b. But let's look at what happens between a and b. Clearly you can see that it is decreasing here from a to b, and then when it reaches b, it turns, hence turning point, and it starts increasing once more. It has a positive gradient, and here between a and b, it has a negative gradient. So we say that it is decreasing there. So the answer to 9.1, for which values of x is f decreasing? F is decreasing between 1 and 5 over 2, right? The x value of a and the x value of b. That's where it is decreasing. In between, at a, it is neither. It is stationary. At b, it is stationary. It is decreasing between a and b. So we're not supposed to include 1 and 5 over 2, which I think probably, most definitely, some people did include those 2 points. But if you think about it, we're not supposed to include them. The function is stationary at a and b. That's why the turning points are sometimes called the stationary points. Okay, so that is 9.1. What about 9.2? Write down the x-intercepts of f prime, the derivative of f. So the x-intercept, right, is at the turning point. The x-intercept is at the turning point. So when x is equals to 1, we have an x-intercept, and when x is equals to 5 over 2, we have an x-intercept. So the coordinates, right, of the x-intercept, we're going to have x is equals to 1, y is 0. X is equals to 5 over 2, and y is 0, right? So that is how it works. The stationary points of the cubic function will give you the intercepts of the derivative, which is the quadratic function. So that is 9.2. And then 9.3, for which values of x is f concave up. So take a look at this. Take a look at this. From here, right, up until somewhere in between here, somewhere in between, it is concave down, as we can see, but the concavity changes. And then now it becomes concave up from this part up until infinity. So we need to find this point where the concavity changes. It is called the point of inflection. How can we find that point? We can say that x is equals to x of tp1 plus x of tp2, right, divided by 2. That's where we're going to find our point of inflection. So x is equals to 1 plus 5 over 2 divided by 2. What do? I put that in my calculator. So 1 plus 5 over 2, everything divided by 2. I'm getting 7 over 4. So x is equals to 7 over 4. So this point that we're interested in between a and b, it is 7 over 4. So we're looking for the values of x for which it is concave up. So from 7 over 4 up until infinity, it is concave up. So what are we saying? We're saying that x can run from 7 over 4 up until infinity, that is 9.3, right? And then it is concave down from 7 over 4 up until negative infinity. Okay, but at 7 over 4, it is neither concave up or concave down. It's confused. It does not know what it is. It cannot identify as one between the two. That is 9.3. And the 9.4, the question that we've done countless times. Maybe let me not say countless times, maybe 5, 6, 7 times, something like that. But then why am I bringing that up? Let me show you why I'm bringing that up. We are looking for the value of k for which y, okay, I'm not supposed to do that. Let me go down. For which y is equals to f of x plus k as 3 positive x-intercepts. We're looking for the values of k for which this thing will have 3 positive x-intercepts. So let's dissect that. Let's make sense of that and see what we need to do. So as you've seen on the previous video, when we are doing this question, let me trace the function first so that I can demonstrate it to you with a bit of clarity. So you will see why I'm doing that. So I want to show you something. Okay, so this is f of x, right? What does plus k do, right? Plus k, it moves the function up and down. If k is positive, it is pushing the function up. If k is negative, it is pushing the function down. That is what k does, right? So do we need the function to go up? No, we don't need the function to go up, because if it goes up and up and up, we are always going to have one negative x-intercept, and we are looking for 3 positive x-intercept. So how do we get to 3 positive x-intercept? Take a look at this. Okay, we take this down. How many intercepts do you have? 1 negative. We take it down once more. 1 negative. We take it down. 1 negative. Again, 1 negative. But when we reach this point, right, when b touches the x, the x-axis there, we still don't have 3 positive. But take a look at this. What happens there? Now we have 3 positive, right? Let me show you why I'm saying we have 3 positive. We have this positive 1 here. We have another positive intercept here, and we have the third one there, right? So when k, which takes the function down. So if k, we have plus k here, so we need to be careful with how we write this. If k is greater than minus 8, our condition is satisfied. If k is greater than minus 8, our condition is satisfied. Because, for instance, if k is minus 8.5, then we achieve 3 positive intercept, right? But it does not end there. There's a limitation that I need to show you. So let's say we keep going down and the x value at a touches the x-intercept, because we would have a here, right? And we would have b here. So you can see that when that, not the x value, but the y value, when that y value at a touches the x-axis, we have a problem. We no longer have 3 positive. So we need k to be greater than -8, but we need k to be less than -9. If these two conditions are satisfied, then we're going to have 3 positive x-intercepts. That is question 9. There we go. Which question do you want me to do next? Question 10, 11, 12? Do we go to 7? Let me know in the comments. Hey, if you think about this, doesn't make any sense, right? Because -9 is less than -8. These are not positive numbers. So we're not supposed to write it in this way. We're not supposed to write it in this way. Rather, we're supposed to say that k should be less than -8, but it should be greater than -9. This is the correct way of writing it, because -8 is greater than -9, right? Not the other way around. I hope nobody made that mistake that I just did there. But anyway, stories. We're doing question 10. Let's go. So a cyclist rode from town P and stopped at town T, right? The speed in kilometers per hour at which the cyclist rode is represented by the equation s prime of t is equals to -3t squared plus 18t. And the first question, 10.1, calculate the maximum speed that the cyclist reached on this ride. And then we're supposed to note that speed is the rate of change in distance with respect to time. I would assume that that note is for people that are not doing physics, because if you're doing physics, there's no way you don't know that. But anyway, stories. We're not here to make fun of people that don't do physics, right? We accept them as they are. But let's take a look at the equation. We are looking for the maximum speed. This is the equation for the speed, and we can see clearly that this is a quadratic equation, right? Of which it is concave down. It should look something like this. So the maximum speed, we're essentially looking for the turning point, right? So what can we do? We can derivate and equate to 0, or we can just say minus b divided by 2a. I saw somebody say, no, we're not supposed to use minus b divided by 2a, we're supposed to derivate. I don't think it really matters. We can do whatever. We get to the same answer. But if we derivate, s prime of t will be equals to -6t plus 18. So at the turning point, the gradient is 0, right? So we know fully well that we're supposed to say -6t plus 18 is equals to 0. T is equals to, well, -6t is equals to -18. So t is equals to 3. So there we go. That is the value of t. But we're looking for the maximum speed, not the value of t for which we are going to have a maximum. So what are we going to do, therefore? Well, let's just prove that this t is indeed equals to 3, right? We can do that by saying t is equals to minus b divided by 2a, of which minus b, that is -18, divided by 2a, a is -3. So we have -18 divided by -6, which is 3, right? 6, 12, 18. So you can see we end up with the same thing, but we need to substitute this speed here, right? And see what, not the speed but the time, and see what speed we get. So 3, 1, 2 plus 18t, that is 1. This is equals to, so let me just substitute that. -3 multiplied by 1 squared plus 8 multiplied by 1. So this is equals to 15. Let me just verify. Plus 18. T is equals to 3. Why am I substituting 1? Why am I substituting 1? This is fatigue. That's what happens when you are extremely tired. So -3 multiplied by 3 squared plus 18 multiplied by 3. And this is equals to 27. So the maximum speed is 27. Let's take a look at 10.2. 10.2, calculate the distance between town P and town T. The distance between town P and the town T. Okay, it's a bit complicated. How do we do that? We don't have, well, do we have the time it takes? Do we have the time it takes? Do we have the time it takes to go from P to T? Do we have that? We are not given the time it takes. Is there a way to find it? Is there a way to find the time taken? So we are going from P to T, right? I think we can actually find the time taken. I think we can. Okay. So at T, we stop at T, right? So we know fully well that the speed here at T is equals to 0 because we stop there at T. But what about P? We should be cycling from 0 at P, right? We should be cycling from 0 because you cannot start cycling at 10 kilometers per hour. You have to start cycling at 0. So the speed is also 0 there. So let's find the intercepts so that we can find the time, right? Because we clearly have a graph of which x is time and y is the speed. So we can find the time. So s prime of t is equals to minus 3t squared plus 18t. So let's find the intercepts so that we can find the time, right? Because where the intercepts, we are going to be able to find the distance between the intercepts, and that is going to give us the time. So minus 3t squared plus 18t is equals to 0. So if we take t as a common factor, minus 3t plus 18 is equals to 0. T is equals to 0, or t is equals to 18 divided by 6. That's 6. So, right, our time t is 6 hours. So this is our time t. We have the time t in 6 hours, and we have the equation of the speed, right? It is equals to minus 3t squared plus 18t. Okay, so I will now proceed and solve this question in two ways. One way of solving this question is to use what we call integral. We need to integrate, right? So when we integrate, essentially the idea is, you can see here that we have s prime of t, right? We have a derivative. So we are asking ourselves, what was the equation before we derivated? And what does that give us? Because this note that we're given, it says speed is the rate of change in distance with respect to time. So it means that before we got this equation, because we can see that it is a derivative, we had the distance with respect to time. And then when we derivate, we get speed, right? So we can ask ourselves, what was the equation that gives us distance before we derivated? That's what we mean by essentially finding the integral. So let me show you how that plays out. So s of t, right? Because now we are finding the integral. So before it was minus 3t squared, what was it? That's the question we're asking ourselves. Because before it was minus 3t squared, what was it? It's it's not too complicated, but that is the question we're asking ourselves. But after we do it in this way, I'm gonna also show you another approach that we can also take. So if we go ahead and use that approach, we're gonna have minus t to the power 3, right? Because if we derivate minus t to the power 3, we get minus 3t squared. Okay, so we can agree that this is before we derivate, or this is what we have before we derivate and get minus 3t squared. And then what about plus 18t, right? Well, we need to have 9 here and then t squared, because if we derivate that, we get 18t. So this is the formula for the distance that we had before we derivated to find s of t, plus c. You might ask yourself, what is c? Well, c is a constant, because we know fully well that when we derivate, a constant falls off. T might be 0, right? Meaning that we had no constant. But we always include it to show that we are aware that we might have had a constant. But when we find in a definite integral, what do I mean by a definite integral? We have t going from 0 to t being equals to 6. Because we have this limit, this is a definite integral. So we're gonna evaluate this integral from t is equals to 0 to t is equals to 6 in the following way. So we're gonna say the distance is gonna be equals to s at 6 minus s at 0. Okay, so let's evaluate this. S at 6, we're gonna have minus, and then in place of let me use bra to show s of 6. So here we have s of 6, right? So it's gonna be minus 6 to the power 3 plus 9 6 squared plus c. Okay, and then minus s at 0. So we have minus 0 to the power 3 plus 9 multiplied by 0 squared plus c. Obviously c and c will cancel out. That's what always happens when we have a definite integral. We don't even have to worry about the value of c because they're going to cancel out. So this is equals to, so we can see that this will give us 0, right? So we can forget about that part and just focus on s of 6. S of 6, we're going to have minus, and then 6 to the power 3, okay, plus 9 multiplied by 6 squared. This is 108. So we have 108. So what does the equation say? Calculate the distance between p and t. So we're talking about kilometer per hour. So 108 kilometers. Can a person cycle 108 kilometers? But that's what we have. That is the distance when we use an integral. But integrating is not part of our curriculum. So which other possible option do we have? Let's evaluate that. So another possible option we have is to find the speed when t is equals to 0, t is equals to 1, 2, 3, 4, 5, 6. We can find the speeds when t is equals to these values, and after we do that, we can just find the average and multiply it by the time. So let's go ahead and do that. So minus 3 multiplied by 0 squared plus 18t. That will give us 0, right? And then when you substitute 1, minus 3 multiplied by 1 squared plus 18t. And this gives us 15. Let me substitute 2. When I substitute 2, I get 24. When I substitute 3, I get 27. What about when I substitute 4? When I substitute 4, I get 24. When I substitute 5, do I get 15? Seems like it. And when I substitute 5, I get I substituted 15, not 5. When I substitute 5, I get 15. When I substitute 6, I think I should get 0. So let's see. I get 0. So yeah, this is the speed for each hour from t is equals to 0 up until t is equals to 6. So we can find the average speed here, right? So the average, I'm not supposed to do that. So the average speed, is going to be equals to 0 plus 15 plus 24 plus 27 plus 24 plus 15 plus 0, right? And we divide all of these by 6 because we are finding the average, right? We know what x bar is equals to. So 0 plus 15 plus 24 plus 27 plus 24 plus 15 plus 0 divided by 6. This is 17.5. So 17.5 kilometers per hour. This was the average speed. So now we can say that the distance is equals to the speed multiplied by the time. So the speed is 17.5. The time is 6 hours. So let me multiply that by 6. When I do that, I get surprisingly 105 kilometers. Oh yeah, here I got 108, and then when I use the average, I get 105. They're very close to each other, so I'm quite happy with my solutions here. Tell me, what did you do for this question? Let me know in the comments. Here we go. Determine how many different codes can be formed if letters and digits may be repeated. What's our scenario? A company generates a 4-character code using the 26 letters of the alphabet and the 10 digits 0 to 10, and the code is in the form letter, digit, and then 12.1 we are supposed to find the total number, right? The question says determine how many different codes can be formed if letters and digits may be repeated. So we have letter, digit. So how many letters do we have? We have 26, right? And then how many digits do we have? We have 10. But repetition is allowed, right? How many different codes can be formed if letters and digits may be repeated? So when we fill the third spot with a letter, we still have 26 options. And when we fill the fourth spot with the digit, we still have 10 options. So the answer here, so that is 26 squared multiplied by 10 squared. 67,600. So there we go. That is the answer to 12.1. Let's take a look at 12.2. Looks like we have some conditions here. Determine how many different codes can be formed if the letters D, F, I, Q, U, and V may not be used. So of the 26 letters, how many are we subtracting? 1, 2, 3, 4, 5, 6. So we are subtracting 6 letters, and now we only have 20 letters, right? Okay, and then the code may not start with a W or Z. Is W or Z one of the letters that we eliminated? No. Okay, that is important to address. Letters or digits may not be repeated. Okay, and then the code ends with an odd digit. Okay, so those are our conditions. Let's go ahead and play around and see what we can come up with. Okay, so we have one. What am I doing? We have 1, 2, 3, 4 spots that we need to fill. So let's start with the spots that have conditions. The spot that have conditions is the first and the last, right? We have special conditions there. So the last spot, the code ends with an odd digit. So how many odd digits do we have? So the digits that we have is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So odd, that is even. Odd, 7 is odd, 9 is odd. So we have 1, 2, 3, 4, 5. We have a possible of 5 digits that can fill the last spot. We have only a possible of 5 digits that can fill the last spot. Okay, so we put 5 there because of that. And then let's come to the first spot, which we also have a condition. The code may not start with a W or a Z. So how many letters can possibly occupy the first spot? We have only 18 letters that can possibly occupy the first spot because we have removed 6, right? Because we cannot use them anymore. But of those 20 that are remaining, we have 2 that are not supposed to occupy the first spot. So we have 18 there. And then the second spot, do we have any condition there? No, we just need a digit, right? But we have already exhausted 1 digit on the last spot. We have exhausted 1 odd digit. So of the 10, we are left with 9 here on the second spot. So there goes 9. And then on the third spot, we've already, of the 20 letters, right? We've already used 1 on the first spot. So we're actually left with 19 there on the third spot where we need to assign a letter. So let me put this in my calculator. 18 multiplied by 9 multiplied by 19 multiplied by 5. This is equals to 15,390. So W or Z, they should not occupy the first spot. Okay, so I'm quite happy with what we've done there. Okay, this is the answer to 12.2. Let's take a look at 12.3. 12.3 is just out of 2 marks. So I want you guys to let me know in the comments. How did you answer this question? Calculate the percentage increase in the number of different cones that can now be formed. Right. So how did you answer this question? What is your solution? Can you write it down in the comments? I'd like to see what your answer is. There we go.